Now let us discuss how to delete an element at the end of a given single linked list. Case 1, when start is equal to null. See, start only equal to null means there are no elements in the linked list, there are no nodes in the linked list, the linked list is empty. When the linked list is empty, what we can delete? We cannot delete anything. There is no single linked list and hence deletion cannot be done. Therefore print a message, deletion cannot be done as list is empty. This case is very simple. Case 2, when start of next is equal to null. See, start will always contain the address of the first node. Start of next only equal to null means there is only one node in the linked list. There is only one element in the linked list. When there is only one element in the list. Yes. Start is containing the address of this node 10 and you can just see start of next equal to null. There is only one node in the linked list. And when there is only one node in the linked list, that node only is the first node, that node only is the last node. So this is our last node and we have to delete this node. First, let us have a temporary pointer, that is temp is equal to start. Yes, temp is equal to start. Now, start is containing the address of this node. After deleting this node, start automatically will become null, because after deleting this node, the list will become empty, and the list becomes empty means start should be equal to null. Therefore, make start equal to null. Start equal to null. Very good. After that, display the deleted element also. So deleted element is temp of info. Temp of info is 10. Yes, display 10. Next, free the memory which is taken by the node pointed by tab. That is free tab. Because we are logically deleting and physically we are deleting using this free tab. And return start. That's all. Very simple. Both the cases are quite simple. When there is only one node, delete that node, make start equal to null and return the node which is pointed by temp back to the operating system. That's all. Both the cases are quite simple and straightforward. Now, let us discuss the third case, when start of next is not equal to null. See, when start of next is not equal to null, it means more than one elements are there in the linked list. When more than one element is there in the linked list, yes. So this is our list. Yes. How many elements are there in the list? 5 elements are there in the linked list. 10, 20, 30, 40, 50 and start is containing the address of the first node. Now, which is the last node? The last node is 50. So we have to delete 50. And carefully understand how to disconnect 50 from this linked list. If you have to disconnect 50 from this linked list, the address part of 40 should become equal to null. If you want to make the address part of 40 equal to null, you require a pointer to 40 also. Meaning, if you have to delete 50, you require a pointer to the node 50 and also you require a pointer to the node 40. Very important. Yes, we have to delete the last element 50 in this list. Neatly understand? Very important point. To delete the last node, we not only require a pointer to the last node, but we also require a pointer to the previous node of the last node. Yes. So in this list, the last node contains 50 and the previous to last node contains 40. So you require a pointer to 50 also, you require a pointer to 40 also. Yes. We have to traverse the list to get a pointer to the last node. So temp should contain the address of the last node. We will use temp so that it contains the address of the last node and follow to point to the last but one node. Meaning we have to traverse in such a manner that temp will contain the address of 50 and follow will contain the address of 40. Yes. Now we will have a temporary pointer. We should never traverse using start. Yes, initialize temp to start. Yes, temp is equal to start. Now, we should go till the last node. Meaning, when do we come to know that it is the last node? When the address part of that node equal to null, it is the last node. Therefore, when temp of next is not equal to null, it means it is last. It is not the last node. When temp of next equal to null, it means it is the last node. So, since right now, Carefully understand. Temp is containing the address of 10. Right now, temp of next is not equal to null. Yes, temp of next is not equal to null. Temp of next is containing the address of 20. Temp of next is not equal to null. Therefore, follow is equal to temp. Yes, and temp is equal to temp of next. Very good. Next now, temp is containing the address of this node 20. Temp of next, is it equal to null? No, temp of next is not equal to null because temp of next is containing the address of the node 30. Now, since temp of next is not equal to null, follow is equal to temp and temp is equal to temp of next. Again, follow will become temp and temp is equal to temp of next. Yes. Now, again, temp is containing the address of the node 30. What is temp of next? Is it equal to null? No, temp of next is not equal to null. Temp of next is containing the address of the node 40. It is not null. Therefore, since temp of next is not equal to null, follow should come to temp and temp is equal to temp of next. Yes, follow will come to temp. Yes, temp is equal to temp of next. Yes. Now temp is containing the address of the node 40. Temp of next, is it equal to null? No, temp of next is not equal to null because temp of next is containing the address of the node 50. Yes, since temp of next is not equal to null, follow is equal to temp and temp is equal to temp of next. Yes, follow will come to temp and temp is equal to temp of next. Now, carefully understand what is temp of next. Now temp of next equal to null. Temp is containing the address of the node 50. Temp of next equal to null. So temp of next equal to null, meaning temp will contain the address of the last node and follow will contain the address of the last but one node. Now temp of next is equal to null. Temp is pointing to the last node and follow is pointing to the last but one node. That's what we wanted. Now we'll write the while loop. In the coding, we'll do the while loop. So when should we continue the while loop? When temp of next is not equal to null. That is, while temp of next is not equal to null, what are the two things that we did? Follow is equal to temp is equal to temp of next. When you come out of this while loop, temp will contain the address of the last node, follow will contain the address of the previous to last node. Very good. Now, how to disconnect 50? Very simple. Address part of 40 should be made null. Who is containing the address of the node 40? Follow. Therefore, follow of next is equal to null. Yes, let us make follow of next is equal to null. Before that, we will display temp of info also. Yes, after that, follow of next is equal to null. Yes, follow of next is equal to null. Then, whatever is the node which is pointed by temp, we have to free it. Therefore, free temp and return start. That's all. We have disconnected the last node and we have deleted the last node also. We have freed that node also. Very simple. When there are more than one number of elements, how to delete the last node? Yes, this is the logic. I think this logic is very simple. Now, let us directly go to the function. Delete SLL end, meaning delete at the end of a given singly linked list. The address of the linked list is given and the function returns a pointer of the type structure of the type node. Okay. Now, there are two temporary pointers, follow and temp. Very good. Start is equal to null, display a message. Deletion is not possible as list is empty. That's all. If start of next equal to null, it means only one node is there. Already we discussed the logic. Yes. Otherwise means more than one number of elements should be there. Temp is equal to start. Just now we discussed temp of next not equal to null. What are the two things that we did? Follow is equal to temp and temp is equal to temp of next. And after that, display temp of info. Follow of next is equal to null. Free temp and return start. That's all the function for deleting an element at the end of a given singly linked list. Three cases are there. Start is equal to null. Start of next equal to null and start of next not equal to null. That's all. I think this logic is quite straightforward, nothing difficult.